Now question is where to jump if an interrupt comes. So interrupt comings mean is really is this, right? When your printer job is done, for example, at that point your application program get halted and control being transferred to the interrupt service routine. So this is what is meant by when the interrupt comes in. So some mechanism intervene and stop your user program, and pointer or control jumps to the interrupt service routine. Now where to jump? Processor jumps to a fixed location. Okay. IO device handshake on the device identification, and basically when interrupt comes from a specific device, it includes the information of which device has caused that interruption, and then corresponding interrupt service routine is called, or your control jump to the corresponding device driver or interrupt service routine for that device. So that means like when any interrupt occurs, your program counter changes to a specific location, and in that location basically first part of the code is to look at the interrupt code, it's interruption device code, which is stored in one fixed register. We'll come to that. And then it goes to corresponding devices interrupt service routine. Now, second part is how to resume user program after interrupt. Basically store runtime environment, and this time it includes all the registers except for 0, K0 and K1. Except for these three registers, all other registers including temporaries are saved before anything being done at the ISR level. So at the entry point of the ISR or before the ISR is called, all these registers are saved except 0, K0, K1, because 0 is constant, K0, K1 are to be used by the operating system kernel, so it is usual that they will just get changed, those part. And then when you are returning back from the interrupt service routine, you basically restore the RTE before return to the user program. So that's how you make it transparent to the user program, apart from the fact the user program is halted for some time and then start and resumed its own process. Now other question is, what if an interrupt comes during an interrupt service routine? It can happen, it's a physical world, right? So there has to be some interrupt disabling mechanism through which system tells, hey, I'm not going to take any more interrupt because I'm busy in another interrupt servicing. And on top of that, we possibly want to build a priority mechanism, because some of the interrupt service is probably lower priority than other higher priority of interrupts. For example, like if let's say there are like we'll see there are some user defined interrupt and which is called an exception mechanism. Those basically are less important than if some interrupt comes from the printer or something from the disk. For example, like it's writing, it failed and it's interrupted and need to intervene in that. Those are higher priority than user defined soft interrupt, we'll say, or exception as we say. So during the lower priority of interrupt service, higher priority of interrupts can come in and intervene in middle, but not the lower priority interrupts can stop and higher priority interrupt. That's the whole mechanism we need to develop in a computing system. Now about the exceptions, since I mentioned in the previous slide, Exception can be imagined as an internally generated interrupt, means internally to the processor. It is being generated from the processor itself. So interrupts in general is coming from the external devices or the peripheral devices. But exception you can imagine for the internally generated interrupt. Exception is a mechanism to handle exceptional runtime situation in an application program. Processors, there are some native processor generated exception like divide by zero or unaligned address access. And user program also can generate exception like throw and catch mechanism in Java and C++. Those are user defined soft interrupt, we can call it, or they call it usually an exception mechanism. So this is what has lower priority than your real physical, maybe like disk is out of space, or there is some communication needed to be done from the disk driver or printer or keyboard. Those are usually of the higher priorities.